Welcome to this short video presentation on cognitive information processing theory. I hope you find this to be informative. First, I will introduce the cognitive information processing theory, then I'll briefly discuss how about the theory came about. Following, we will take a look at a diagram of the model and the three memory systems, and finally I will provide some ways that you can apply this concept in the field of instructional design and technology. Cognitive information processing theory acknowledges the environment as playing an important role in learning. It views learners as active seekers and processors of information. To give you a little history that will help you understand the theory, the birth of computers after World War II provided a new perspective on learning. The computer provided a new metaphor for human information processing. It gave us a language for describing it. This caused a shift in the way that memory, perception, and learning were thought of. According to Mary P. Driscoll, the author of Psychology of Learning for Instruction, stimuli were thought of as inputs, and behaviors were thought of as outputs. And what happened in the middle was considered information processing. Let's take a look at the cognitive information processing figure on your screen. As you can see, it shows a linear progression of boxes going horizontally from left to right. Note that the sensory inputs points to sensory memory, which is information that one is exposed to visually and auditorily. Sensory memory points to short-term memory. This is also referred to as working memory. It is where processes such as chunking and rehearsal help in encoding information for long-term memory. The short-term memory box points to a box labeled long-term memory. You can see that this arrow is labeled with a process called encoding. The long-term memory also points back to short-term memory. Note that this arrow is labeled with a process called retrieval. Let's look at the three stages a bit more in detail. Sensory memory holds information associated with the senses. Such information is what one is exposed to visually and auditorily. This information is retained just long enough for information to be processed further and either placed in short-term memory or lost. Consider the image of the airport on your screen. Sensory memory contains information about what the senses attend to. In other words, what is seen and heard. Think about the last time that you flew. You likely had to remember your flight and gate number, which brings us to short-term memory. Short-term memory holds information for a limited amount of time and holds a limited amount of information. It can hold roughly 7 to 10 bits of information at one time. It functions as temporary working memory, whereby further processing is carried out to make information ready for long-term storage or response. At this stage, concepts from long-term memory will be activated for use in making sense of incoming information. Unrehearsed information will be lost from working memory in about 15 to 30 seconds. The capacity for working memory can be increased through creating larger bits by using a process called chunking. This is a learning task should be organized and grouped so that learners can easily chunk them. Consider the image on your screen. The first is a visual representation of a long list of numbers. It is likely that you would have a difficult time remembering this as it is. However, by grouping and chunking the numbers into bits, it makes this an easier task. Think of your telephone number or social security number, which are both grouped bits of information. Long-term memory represents our permanent memory storage house. It is capable of retaining an unlimited amount and variety of information. To prevent loss and ensure that information is transferred from short-term memory, you can use a process called encoding. Encoding refers to the process of relating incoming information to concepts and ideas already in memory. This makes new material more memorable. Information can be encoded by organizing and grouping it into categories, creating outlines, establishing hierarchies, and constructing concept maps, such as the one that you see I've constructed on this screen. So by now you're probably wondering, how can you use cognitive information processing principles with your instructional design? Here are a few ideas. Provide organized instruction. You can link new materials to what is already known, and recognize the limitations of attention that we've discussed here. Match encoding strategies with what is being taught. Thank you for coming to this brief presentation on cognitive information processing, and for further information, you can refer to the sites listed on this screen.